All right. I'd like to welcome everybody to the Homebrew Robotics Club. This is our first meeting in 2024. And we're very pleased to have Alberto Saragna with iRobot. He's a principal engineer there in charge of the Create 3. Is that right, Alberto?
Yeah, I'm one of the main software developers on the project. I'm not the tech lead personally. Unfortunately, Steven wasn't able to join and do the presentation with me. But yeah.
Okay, and you're in Los Angeles, right?
Yeah, exactly.
Okay, very fine. Small world. Meeting being recorded. Okay, so hereby call this meeting of the HBRC Homebrew Robotics Club January 2024 to order. Let's see, let's start off here with some industry news. Do we have any industry news out there that somebody would like to talk about?
Yeah. The Adafruit has come up with the Peekaboo teddy bear, and I could share a video if you'd like to see it. And
Go for it.
It looks like it's just inviting to be hacked. So let me run it.
Are you sharing your screen?
Give me a second. Can you see it?
Yes.
Just give my left foot a squeeze if you would like to get my attention. How may I help you? Tell me a joke. Let me think about that. Why was the math book sad? Because it had too many problems.
And that's about it. Let me see. It's got all sorts of features. It's let me pull up the back. Yeah, I opened one screen and it closed my other screen. Wonderful. Let's see. Nope, that doesn't work. There we go. Got too many screens here. If anybody else wants to go, I'll just put the link, put the information in the link.
Okay, stop sharing.
Stop sharing.
What other industry news do we have out there? I hate to mention the iRobot stock, Alberto, but it is in the industry news. Amazon was acquiring iRobot, and the stock was up like, I don't know, 100% or something. I think it's up $50. And over the past month, it's dropped like 50%. It's gone from $40 to $14, I believe. Basically, the European Union, what were they? They were contesting the acquisition, so the acquisition didn't work. And so, anyways, iRobot's back on their own now. We wish them the best. Right, Alberto?
Yeah, thank you. Unfortunately, it's going to be a hard time for the future, but yeah, we'll try to do our best.
It's never been easy. Let me share my screen here. I've got some other industry news here. And that's the latest video from Elon Musk with Optimus here. It's got Optimus walking. At least it's not a dude in a suit anymore. I was reading something about their self-driving cars too, the autopilot, and it seems they've got a neural network going now that's completely displaced, the algorithm that they had run. And, they're actually, of course, Elon Musk is touting it as full self-driving. I've also read something about his Neuralink. Looks like they're doing some implants for quadriplegic people to get them to be able to control their computer because they don't have use of their hands. And so that's an interesting thing. Any other industry news out there? Anybody got?
Just a clarification on the Neuralink. I think they've done one, and just very recently.
Very good. Let's move on to club news, okay? Club news right off the bat is Robo Games is coming, and I'm actually going to be able to make it out there again. Let's see here. Yeah, so it's Robo Games is April the 18th through the 21st, and it's going to be at the San Jose Convention Center. So don't be a spectator, get a robot together. That's the best way to see the show. We do the TableBot challenge. That's a good one to get into, and you've got plenty of time to build your robot for that. And there's also the Robo Magellan, where the robots find a GPS coordinate. We're going to run that in a park that's nearby, so that should be interesting. So that's Robo Games coming up April the 18th through the 21st. And there's also this, so much for you. There's also Robots on Ice. There's a little bit of a conflict there. Right? Marco, is that your robot out there on the ice? Anyways, that's Marco's robot, and there's Rocky back there. All right, that was a couple of years ago, I believe. But yeah, this is like Maker Faire Robo Games, but it's on ice, and that's going to be April the 21st. Unfortunately, there's a little bit of a conflict with Robo Games there, but this will be more in the evening. So, and Robo Games is Saturday and Sunday. So, don't be a spectator. Participate. Build. Is there any other club news out there?
Hey,
George,
Camp, this is Al. FRC season started first weekend of January. This year, the Silicon Valley Regional is not going to be in April competing with Robo Games like it's has always traditionally been. It's going to be at the end of February, beginning of March. And it's not going to be at San Jose State as it's been for the last 20 some odd years. It's going to be at the county fairgrounds. So they're always looking for volunteers. And I know Marco has always been a referee at many.
Yeah. So get involved with the First Robotics. They also have Lego League and Vex Tech. I'm working with a Vex Tech group here in Tallahassee. They're doing their thing. But so the first event's coming up when?
It's end of February, beginning of March.
Okay, and it's going to be where?
First weekend in March.
Oh, you guys are throwing rings this year, aren't you?
Yeah, they call them notes, and they're these foam donuts that are around 14 inches, and they're squishable. So it's kind of interesting. And it's a musical theme. It's a challenge. It's a pretty challenging game. And be interesting to see what some of the kids come up with.
Very good. That's First Robotics coming up end of February. Okay. Next segment of the meeting. What I need help with. Is there anything particular someone needs help with? Thomas, are you getting your Linux class? Are you learning about Linux?
Yeah, I signed up for a course in Linux. I really need to fill in a lot of the holes. I mean, I know a lot, but not not even able to get anything done.
You stick with Ross. You stick with Ross, and you will learn Linux.
Yeah, I am little by little.
So we did some good stuff with the Ross discussion group. We've actually got the let's see if I can find it here. Yeah, so there's some of us working on something we call the mock turtle bot, and here's two of them. On the left, I call it Smarty 2, and on the right, it's Smarty 1. But there's some mapping. Oh, I know. At the yeah, that's the ultrasonic cone. We got the ultrasonic cone going in the RViz, so that's kind of cool. Oh, I'm not sharing my screen. I'm sorry. Let me share my
Not
screen.
sharing your screen.
Yeah, so there's the ultrasonic cone, and it's got a camera on there too. But we're working on a project called the Mock Turtle Bot, where we'll build the turtle bot with either a Create 3 or a BotVac or a regular Roomba. Add the LiDAR. The BotVac's got the LiDAR here. I've Velcroed on an LD06. We've got the OAK-D camera and also just a regular Logitech webcam. And there's a sonar package that we developed in the Ross discussion group, thanks to Mike Wimble and Ralph Gannock. So, all right, I think that broke into show and tell. Is there any show and tells? Nathan, you want to do your show and tell there?
I have some show and tell too.
Okay.
I've got something.
Okay, Nathan's on site there. Nathan, are you? Let's see. Can we spotlight that camera? That's the Ralph Hips camera.
Yeah,
One of the mouse be facing away from him.
there you go.
Yeah. Can you do your demo, Nathan?
Well, it's not so much of a demo or anything. I just kind of, things came off the 3D printer earlier this morning, so don't really have it doing much of anything yet. So it's putting together a simple little line follower for the NASCAR competition at RoboGames. So I can take it apart in a bit, but basically this was the first time that I really ever did. So I had the entire PCB put together for the robot as like a single component. It's the first time I've done a couple of like custom PCBs before, but for this is the first time I really did anything with the part count of small components that I did. So pretty much everything except for the Pi Picos, like 0.5mm QFN, did everything with like a solder stencil and a hot air gun. So I can take it apart and show that in a bit. But I was so very happy that when I put it together with no solder bridges, so it's just, I took it off the rework station, it came out and everything worked. So, or it passed all the validation. So I mean, it doesn't do anything yet, but basically just tiny little, I'm trying to go for, the idea is try to go, since it is the NACR thing, I was trying to go as fast as I can, but so I'm trying to target like 2 or 3 meters a second.
Can we get a closer look at it?
Yeah.
There we go.
Yeah. Yeah.
Are you gonna compete in Robo Magellan again, Nathan?
Yes, I am. I'm gonna bring our Magellan bot.
You got the gold medal last time, didn't you?
I got the gold medal last year.
Excellent.
So need to do some. I gotta up my game a little bit, do some upgrades. But, that's pretty much it for me. So.
That sounds good. Okay. Is there anybody else on site there with a demo? Quick demo? Alan, you got something real quick?
Yeah, hope people can see this. This
Share your
is
screen.
this is
Oh,
called
I'm sorry, highlight him,
okay.
Thomas.
Yeah, I'm going. Yep. There you go.
Okay, cool. Thanks. So this is the XRP experiential robot platform, which confuses me because I like to say experiential platform robot because I'm naturally dyslexic and that causes problems. Anyway, this is like an ideal turtle bot. I mean, not turtle bot, table bot, in that it's 3D printed. It has a Raspberry Pi, or the Pico, so it's a Raspberry Pi Arduino chip. It has two encoded drive wheels, has an IMU chip, has a sonar range sensor, has a line sensor in it. It's powered by 6 volts, 4 AA cells. What else? It has expansion ability in that it has 2 extra motor ports, has a servo, has extra servo port, and has 2 extra sensor ports. It has a micro USB connector. So, and it also has Wi-Fi on it. So the configuration is initially, once you get the firmware loaded, it comes up as a access point, and then you can get to it through its own miniature web host and connect it to your network. And that's about as far as I've got.
Is that from SparkFun?
That is, you can get it from SparkFun. I think to the general public, it's like $125.
Can you post a link in the chat?
Yeah, I will. And it's experiential robot.com. So I will post that. And I think it's pretty good. It'd be pretty easy to do a table bot with this using the line following sensor to do one. And it does have has an arm on it. So you could maybe actually capture a device, except the arm's on the back, not the front. So you have to be kind
Interesting.
of clever on. But you
All
can
right.
move. Everything's 3D printed, snaps together. The only thing that required a screwdriver was the screw on the servo arm.
Yeah.
Everything else is snapped
Yeah.
together.
What's the price
So
tag?
that was a pretty neat idea. And the other thing is, it's designed for first teams, so you can get into they have their WPI has their own free version, well, VS Code. They have their own VS Code version, so you can program it in Python, C++, Java.
What's the price
And
tag, Alan?
125.
Okay, super fine. Thank you very much. That's awesome.
Right, I'll post that link.
Yeah, appreciate that. Jim, you have a demo of Big Orange?
Yeah, I think there were some other people in front of me, but
Let's make it quick. Go ahead and do your demo.
yeah, so I have an update on, give me a share here. Here's the video.
Hey, Orange, retrieve the bottle and bring it to me.
So this is in a series of efforts to retrieve a bottle with a little claw there.
Okay, I'll search for a bottle and bring it back to you, Jim.
So this adds the ability to turn to the sound of the person's voice and then remember where he is or she is. Then it does what you've seen before here is to find the bottle using the stereo AI cameras.
I found the bottle.
It uses 2 cameras, like one on the top and then one on the bottom, it switches so it can get a better view when it gets close enough, because the tray's kind of in the way. And then it's got this little claw, this little grasper that is not really that great and can barely fit anything, but and what it does is it uses a sonar there as well, and so it uses a camera to detect the object using the tiny YOLO model, which is it's a bottle object, and then uses a sonar once it's close enough to try to find it or to center it, and then capture it. So and then it captures it, and then it's going to go back. So it does not work every time. It works once in a while, but kind of. I don't know.
That's why we have video.
Yeah,
Now I'll bring it
I
back
did
to
do
you.
live demo of it, and with a few tries in a live
How did
demo,
that go?
I can get it. I have to do it live, or at least attempt.
I hear you.
I got
I
it
hear
to
you.
pretty much function with a little assistance or a few tries.
Hey, this is awesome, Jim.
I have a bottle for you. I'm releasing it now.
So it brings it back to the person that it saw. And that's it for.
Yeah, that's very awesome. That is a
Thank you.
TableBot Challenge Phase 3. That's very hard to do. Thank you very much, Jim Danugio.
Thank you.
Okay, does somebody else have a show and tell that we
I've
can
got-
get through quickly here?
I've got one that's real quick,
Go
Cap,
for it,
George.
George.
Okay. Okay, let's see. I've been kind of surprised that there hasn't been more interest in the VIAM software. I seem to be the only one that's really doing. I
Oh,
put out a
VM?
general message. Yeah. And remember, we had the October presentation. And anyway, I've pursued that.
They're hiring, George.
So, well, it's kind of a fun thing. So here's, let's see, I got to get the right screen up here. Just a second. Be real quickly here. Okay, so I have a picture of it that I can get up here. And then, let's see, I need to do a share, I guess. Here we go. Okay, so I've got a Raspberry Pi hooked up to a motor driver. And look what I'm driving here. This is a vintage 1870 telegraph sounder. So does that qualify for the arm challenge if I can move it? Okay.
That's a
So,
stretch.
okay, so let's go take a look here and I'll bring up the video, which will just take a second to get it up here. Okay, get the video. I have the video of it actually operating. Now, it turns out that this is non-trivial. I've got it sending the entire Morse code A to Z and the numbers and question mark and period. I've got it doing all of that right now. Okay, here it comes. Let me get it shared again. Now, I'm working with one of the support people in regard to why I can't get it to do functions. It turns out you have to add a considerable amount of code to communicate with the VIM software. And let's see, it's going to come up just a second.
VM's cloud-based, isn't it?
Now, I'm kind of, like I said, I'm kind of surprised that nobody else has kind of picked up on this.
VM's cloud-based, aren't they?
Yeah, it's cloud-based. Some runs locally, I think, though.
Yeah, George, all we're seeing is a black screen there. I put a link for VM in the chat. Did we lose George? I don't see him. Okay, do we have another show and tell out there real quick? Hey, Dillo.
Hey,
Oh, there you are, George.
I got it. Oh,
Did he say he has something?
Yeah, but his audio's not coming through. Dillo, your audio's not coming through.
Video's frozen.
Yeah. Okay, any other show and tells real quick? We want to get to the presentation. All right. Well, let's move on to the presentation then. Here we have Alberto Saragna is a principal robotics engineer at iRobot. He did the presentation at RossCon on the Create 3, and I really like the Create 3. I think it's a fantastic I recommend it. And I'm a big fan of the BotVac, but I find that the Create 3 has superior suspension, and I like the way that it it comes up and just runs those ROS2 nodes and exposes those topics, and it's a great way to start off and learn ROS. So without any further ado, Alberto Saragna, welcome you to the Homebrew Club.
Do you hear me well, or do I need to adjust my microphone?
Let's adjust that microphone upward. Can barely hear you.
Is it better now?
It's better now.
Okay, perfect.
It's good.
Okay, so as you said, I'm gonna present a little bit the challenges and the experiences that we learned developing the Create 3 at iRobot. Before starting, I really want to make clarification. As you pointed out at the beginning, iRobot is currently undergoing some financial problems. Since Monday, we announced that we are going to lay off a large number of people, and the education program is going to be paused temporarily. So this will affect Create 3. I don't know anything more than this. I mean, I discovered everything on Monday. So I just wanted to mention this before the presentation. Okay, and with that out of the way, let me share my screen. Okay, perfect. So in this presentation, I'm going to cover a few different topics. First of all, I'm going to describe a little bit the history around the Create 3. And then I will focus on the architecture, both hardware and software for this robot. The main part of the talk will be about the challenges and the different solutions that we implemented to make this robot possible. And lastly, I will discuss a little bit what we learned from the Create 3 community and how we are seeing this robot being used out there. So the first iteration of Create is actually from 2007. We started by repurposing old Roomba discovery robot and allowing people to hack with it. These are images from the first Turtlebot that was created out of this robot. We always wanted to make sure that our platforms were available for hackers and engineers to play around and experiment on their own. This first iteration was very rough, but we saw that people were interested in it. So years later, in 2014, we did a second version of this robot, the Create 2, again starting from a Roomba with some slight modifications, in particular removing the cleaning apparatus and exposing some serial interfaces to program the robot. This was definitely a step forward with respect to the first Create, but still it was not very easy to be used out of the box from our users. That was definitely the main challenge that the Create 2 users had. In the meantime, an important change that happened in our company is that we acquired Root Robotics. Root Robotics developed the Root robot that you can see here in this slide. This robot is mostly targeted at young people trying to learn how to program. Indeed, you can go from block coding with pictures moving that you can move around to some sort of structured programming language. And finally, you can get to full Python. This is, I think, a great robot that can onboard children and teach them the main ideas around coding in a fun and engaging way. Most importantly, thanks to this work, we also got a lot of expertise around how to engage with our community, how to develop learning activities, and how to structure classes and other activities around our robot. With all these lessons, we decided to create the Create tree. This is, again, started from a Roomba robot, in particular the i3 robot. And the main selling point for this robot is that it should have been easy to use out of the box.
Alberto,
Yes,
we're still
sir?
looking at the Roomba Discovery series on the screen.
Really? Oh, okay. Let me. Are the slides moving now?
Now we're looking at Root. Yeah.
Okay, I'm sorry. Okay, yeah. So this is the route that I was talking about before. Sorry about that. You can see here an example of the block programming language that I mentioned before also, and the different levels to get to full Python. And okay, just to confirm, are the slides moving now?
Yes, we see the Create 3 now.
Great, perfect. Okay, so and this is the Create tree. The main points of the Create tree are the following. We wanted the platform to be robust. That's why we started from the i3 Roomba robot, which leverage all our experience in creating robust and affordable mobility platforms. The i3 robot is a very low-cost robot. It's the lowest cost robot that we sell at the moment, but it's capable of SLAM, simultaneous localization and mapping. It's in big houses up to, I think, 100 square meters or 200.
Alberto, you say the i3 is capable of SLAM?
Yeah, it is. We recently did a paper on that. I can send you the link to the paper, so I can also talk about a little bit about the SLAM algorithm of the robot. But yeah, that's a very interesting research project that we took, because the i3 doesn't have a camera and doesn't have a LiDAR. So,
well, yeah, that's why I was asking. How do you do SLAM without a camera or a LiDAR?
well, it's not easy. We do SLAM by bumping into obstacles, essentially. When we follow, so we have an obstacle following algorithm. So when we see a furniture, we start following around it. And so we can understand its perimeter. We extract features from this. And thanks to the sensor fusion of the dead reckoning estimation of the robot, we have a pretty good estimate of where the robot is, and we can disambiguate even similar furniture or similar perimeters of the object. This is obviously not as robust as a LiDAR or camera-based lens system, but it's perfectly suitable for indoor SLAM systems. That was really one of the main advancements for the i3 robot. And indeed, all the sensors of the i3 are exposed via ROS topics on the Create tree robot. So now that the paper is available, users are more than welcome to try to re-implement our SLAM algorithm and see if they can achieve the same or better results. Well, all this is really possible thanks to ROS2, because it provides a standard interface through which users can immediately communicate with our robot. They don't need to do very complex setup. They just need to connect the robot to the Wi-Fi, and they will be able to either command the robot via the standard twist, like linear and angular velocity commands, and subscribe to all the topics, for example, including the sensor data, or other information about the state of the robot. In addition to this, we also wanted to allow for more advanced applications, and the Create tree allows to connect via USB with other with other small computers like Raspberry Pi and Jetson Nano. With this connection, you are able to communicate directly between the Create3 robot and your small computer. And that will allow you to develop algorithms in full autonomy without the need of a laptop that communicates with the robot over Wi-Fi. Then one of the other main points for this robot is that we wanted to make it as plug and play for new interfaces as possible. Indeed, the top plate of the robot that I'm going to show in more details in the next slide is all perforated and allows to easily attach a payload to it. Lastly, we think that the Create3 is the perfect next step after the different learning experiences that you have with Root. Indeed, even if the main way to interact with the Create3 is through ROS2, the robot also supports a Bluetooth interface. And with that Bluetooth interface, the robot can be controlled with the iRobot coding platform application. So essentially, you can use the same block programming languages that you learned with the Root to control the Create3. Obviously, you have simplified interfaces and not as much control as you would have through ROS2, but we think that is a very important stepping stone if someone is not familiar with ROS2 already, and they first want to learn how the robot should behave. Now I'm gonna go quickly over the hardware and the software architecture of this robot. As you can see here, we started from the Roomba i3, and just by looking at the exterior, it may seem that the robot is very simple to develop. We just changed the top and removed the vacuum and the bin from it. However, the reality is a little bit different, and this change is not straightforward. We had to develop custom tools for our factories in order to allow the users to easily access their small computers like Raspberry Pi. And we also had, as I said, to develop this new faceplate. And lastly, we developed a customized adapter board.
Alberto, are the ballast blocks just for weight?
Yes, they are. This is where usually you have the vacuum, you have the weight of the vacuum. So without that, the robot would not be as stable as the standard Roomba robot. And yeah, in the robot, you can also find this adapter board, which is what allows you to communicate through BLE or attach additional payload to the robot. This is a very simplified schematic of the electrical components that we find on the robot. We have essentially a microcontroller where most of the sensors are connected. We have this optical flow sensor, which is essentially just the mouse, like a mouse optical sensor. This is extremely useful for robotics, for indoor robotics application, because as you know, if you use wheel odometry, you are not going to get very good results due to wheel.
Is that flow sensor what you use for your SLAM?
I mean, yes, those are all the sensors that we use. We have the optical flow, IMU, and wheel odometry. We fuse them together to compute the dead reckoning estimate of the robot. This is accurate over short distances. This is perfect for relative motions, like if you want to tell the robot drive straight 5 from the current.
So these three processors in that chipset, that's the processor board that's in the i3, right?
Yes, this is the same hardware that is available in the i3. The first three here that you see, like the mobility microcontroller, the supervisory microcontroller, and the power microcontroller, are what we consider to be the low-level microcontrollers of the robot. That's where we have soft real-time operating system, where we interface with the hardware. Then the navigation chipset, you could consider that the equivalent of the brain of the robot. That's where we have the SLAM algorithm, where we have the behaviors and all the user interface capabilities.
Are you guys using micro ROS?
No, we are not. We explored micro ROS a few years ago. I think that micro ROS is great for certain use cases. For example, if you have extremely limited resources, devices, like for IoT, for example, you have a lot of devices with extremely limited resources, and then you have a main compute board, which is not that limited in resources. In our case, for example, our main compute board would be the navigation chipset. And as you can see here, 128 megabyte of flash, 64 megabyte of RAM. This is still limited in resources and it's not powerful enough to take advantage of micro ROS. I mean, you could run micro ROS, but it would be very expensive for what we need in this scenario. The mobility microcontroller doesn't use ROS. We have just a proprietary application there where we interface with all the sensor drivers. And then again, a proprietary communication protocol that sends all this sensor data from the mobility microcontroller to the navigation chipset. The navigation chipset is where we run ROS2. And well, yeah, we also have the adapter board, which is what manages the Bluetooth and the USB interfaces.
So the i3 has Wi-Fi, right?
Yes, the i3 has Wi-Fi. The navigation chipset. That's what the robot uses for connecting to the cloud, for example, when you need to schedule a mission or any interaction with the user. Well, not every interaction with the user, actually, because some of them don't go through Wi-Fi. But yeah, essentially, once you use ROS, you can either directly communicate with the navigation chipset via Wi-Fi, or if you have a Raspberry Pi, you connect the Raspberry Pi via USB-C, and then it's much better because you have way less latency than going through Wi-Fi. Indeed, if you need to do some more advanced robotics application where latency matters, you should definitely take a Raspberry Pi or just a Nano and plug it to the robot, because ROS is not that great over Wi-Fi, honestly. And I'll go into more details about these problems later. Here I'm going to give a quick overview about the navigation application that we run on the Create tree. Just a little bit of the architecture about this ROS2 application. This is responsible for implementing all the robotics logic. On a Roomba, we would have SLAM, behaviors, all the cleaning logic, etc. This is not present on Create tree. This is a custom application that we developed for Create tree. It shares some of the components and the functionalities, especially for the interaction with the hardware, but it's very different in purpose. First of all, it's important to note that it's a single process ROS2 application. So we run a single process with multiple ROS2 nodes inside. This is what is called a composed ROS2 application. It's a very important topic to optimize performance. I know that something like this is doable also in ROS1, for example, where you have nodeless. However, in ROS1, the standard approach was really that you had multiple nodes and each node was in its own separate process. That was one of the main bottlenecks for the performance of ROS2, and is addressed, for the performance of ROS1. And the same applies in ROS2, but ROS2 at least gives you the opportunity to have multiple nodes in the same application. The ROS2 nodes, if you're familiar, they are just C++ classes in this case. This is a C++ application. And you can just instantiate as many as you want in your process. In each ROS2 node, you can create publishers, subscribers, and those will either interact between each other or interact with the user. An important difference between the ROS1 execution model and the one of ROS2 is that in ROS2 we have the concept of executors. So the ROS2 node defines what you want to produce or receive, the input and the output of the system. But the executor is what implements the actual threading model. The executor is what gives execution time to the different callbacks, for example. You have a ROS2 node, you subscribe to a topic, and you define a callback that whenever you receive a message, you want to do something. The executor is what will trigger this callback and will execute the callback. This is important because in a ROS application with extremely tight resources, the layout of your executors, the number of your nodes, these are all parameters that you can optimize to reduce as much as possible the latency and the CPU usage of your system. Then we take advantage of lifecycle nodes. This is a very important feature of ROS2, one of the most important in my opinion. A lifecycle node is essentially a node plus a state machine. The state machine encodes 4 or 5 very simple states like unconfigured, configured, inactive, and active. Through these simple transitions, you can have a controlled startup and shutdown sequence of your system. You can make sure that first you configure all your components and then you activate them. You can make sure that components don't start to talk between each other right away, but you can slow them down and have a sequential startup, for example. This is also important for a lot of other applications. For example, if you want to implement some sort of power saving feature, you can take advantage of this state machine. And when you enter power save, you can deactivate your nodes. Deactivating, for example, would mean that you keep all your nodes, you don't destroy your nodes. They are still there, they are still allocated in memory. But for example, they are not interacting with the executor anymore. So they will not consume CPU. When needed, then you can also unconfigure them, which means also deallocating all the memory, but really depending on what your application needs. This is at a very high level how the application works, all the different components from a ROS perspective. The main CPP of the application is, however, extremely simple because it just consists of creating the nodes, like one line for each node. You assign them to the executors, and then you just run until the user asks to terminate the application. Here I'm gonna. Yes, sir?
If you're using one process, why are you using 4 executors? What's the advantage?
Well, we tested different configurations. We realized through experiments that due to the configuration of our system, having 4 executors was what was giving us the less CPU usage in the system and the less latency. The number of executors you are going to have in your system really depends on the architecture and, for example, on the pipeline of your data. In general, I would say that having 1 executor per node is the default and recommended approach. That's where I would really suggest everyone to start. Then, if you notice something strange or if you need additional customization, you can either increase or decrease the number of executors. Taking into account that each executor will use its own thread, at least one thread. As I was showing at the beginning, the create tree has limited resources. In particular, is a single core processor. So having a lot of threads on a single core processor is not really that useful. Okay, so this is a quick sketch of the sensing pipeline that we find on the create tree. on the navigation chipset. As I mentioned before, we have our mobility microcontroller. We can imagine all the hardware, all the sensors attached to it. Then we have our proprietary communication protocol that sends data to navigation. Here we have a first ROS2 node that will receive all this data. The only purpose of this node is to act as a bridge between the mobility microcontroller and the ROS world. So it will convert all those sensor data into ROS messages and publish them so that the rest of the system can consume them. The main consumers for the raw sensor data are the sensor fusion algorithms that we run on Create3. In particular, we look at the sensor data to compute hazards. We want to understand if the robot is bumping into an obstacle, which is relatively easy because we have bump sensors. So if they are triggering, we are bumping. But we also do some more advanced logic, for example, to detect a kidnap. We refer to kidnap to the situation when a user is lifting up the robot and carrying it away. This is extremely important to detect this situation because while the robot is kidnapped, first of all, you don't want to run the motors because it could create some problems. And also you need to notify your state estimation algorithms because they will likely not be able to accurately estimate the pose of the robot while it's being dragged around by a user. The other important component in this layer is the kinematics engine node, where we again perform sensor fusion, but for the purpose of inertial estimation. Here we synchronize the IMU, wheel encoders, and mouse optical flow messages and compute a dead reckoning state estimation of the robot. This will provide this is the pose, the robot pose that you can get from the creator. We expose both the raw sensor data as well as the sensor fused one, so that users can implement their own dead reckoning algorithms.
Hey, Alberto, I've noticed something when I navigate with my Create3. In fact, this afternoon I was doing some navigation at a makerspace, and it was very cool because when it bumped into something, it backed up and turned the opposite direction. Is that the hazard? Is that the hazard topic?
So that's a separate component. That's what we call reflexes. So I'm going to go into more details on that on the next slide.
Alberto?
Yes, sir?
When you talk about optical flow, are you talking about like a optical mouse sensor on the bottom of the robot?
Exactly. Yeah, it's a relatively cheap mouse sensor. It's really important. I mean, without it, we wouldn't be able to have accurate dead reckoning estimation because of the wheel slippage. That's really what allows you to. I mean, this is because optical sensor is not affected by slippage, obviously. You have other problems. I mean, it's not straightforward to use it because an optical mouse sensor can be fooled depending on the surface on which you are traveling. For example, there are some very strange carpets where an optical flow sensor would be very confused. So it's important to have some processing algorithms that are able to detect those situations. And our sensor fusion layer is then responsible for deciding how to fuse the different sensors at any given moment. So we will know that in some situations the wheel are going to be more accurate, but in other situations the mouse will be more accurate. So the other important topic, other important consumers for all the sensor data are all the autonomous behaviors. On the Create3, we expose some autonomous behaviors which are the same that we have on the Roomba robots. Those are in particular docking, undocking, and obstacle following. The obstacle following behavior that you can trigger from the ROS2 actions on the Create3 is exactly what can be used in theory to develop the SLAM algorithm that we use on the i3 Roomba robots. You can see some videos of those behaviors in action here. Those are fully autonomous, and all the input data that are used to execute them is also exposed to the user. Again, for the same purpose, we are providing you with these capabilities, but we also want to provide you with all the raw data, because it's perfectly doable to implement the same functionalities on a remote machine. It's important, however, to take into account also the latency. For example, if you are going to implement your own obstacle follow, you are not going to be able to do it nicely over Wi-Fi due to the latency of ROS2. This is a very tight behavior. It requires a very careful control at a fast loop. So you will need at least a serial connection with the robot, with the Raspberry Pi, for example.
So, and this may be related, Alberto. Now, the dock action is sweet, because what that means is when you're monitoring the battery power, if it's low, then you can run the dock action and your robot will autonomously navigate. Likewise, you could have it undocked. And I've got a in with the iRobot tech support, and they've talked me through some stuff, including trying different DDS layer and doing not the Omnicast, but I run docking, 10 or 15 minutes, and all of a sudden it goes kaput. It won't connect again until I reboot and that sort of stuff. Any insight into that?
Yeah, I mean, that's definitely, a very common issue. Unfortunately, it's entirely due to the DDS, I mean, it's partially also due to the network stack. This is a relatively cheap robot. You can develop a robot with a much better network stack if you want. However, even on different hardware, even on with much more powerful network stack, we still see these issues, especially over.
Would connecting it to the Raspberry Pi through the, what is it, Ether? You got a Ethernet USB something? Would that help?
Yes, that would definitely help. There's a lot of, it's a very complex problem, unfortunately. There's a lot of different ways, a lot of different actions that can be taken to mitigate this problem. But yes, ultimately using a connection with the USB is what will give you the best results there. This is really one of the problems that I see in ROS2.
They probably used the Raspberry Pi with the actual TurtleBot 4, right?
Yes, exactly. When you have a TurtleBot 4, the user almost always communicates only with the Raspberry Pi, and then the Raspberry Pi communicates with the actual Create tree under the hood.
Roberto, is the perimeter following done by behavior trees?
Can you repeat, sorry?
The perimeter following, is that implemented using behavior trees?
Sorry, I'm missing the last part. Is it implemented as what?
Behavior trees? Question is about behavior trees.
No, it's implemented the behavior tree. We have an internal implementation for this, and it's not a behavior tree. We did some experiments with behavior trees, but we are not currently using them on the robot. I think it's a paradigm, and it can be very helpful. However, for something like obstacle follow, again, you have a very tight control loop. You need to run a control loop at a very high frequency. I personally see a behavior tree more suitable for higher level actions, where you don't need to run your loop that fast.
How fast is your loop run?
So for most of the behaviors, we run at 50 Hertz, but for the wall follow, we run at 200 Hertz.
Okay.
I mean, obviously, it depends also on the computational resources that you have available. If you can afford to run behavior trees very fast and everything, then it's perfectly fine, I guess. Okay, and yeah, here we have it. This is the motion control loop that we run on the navigation chipset. These run at 50 Hertz, and this is what executes most of the behaviors of the robot. It's implemented as multiple threads. We have one thread where we receive user input, because again, this can be controlled via ROS2, so you can send a ROS2 action request. This thread will monitor for these requests and will notify that we need to start executing. And then we have a periodic task implemented in a separate thread with a ROS2 timer. And this will execute the active behavior, if there's any, at 50 Hertz, which is what we use for most of the behaviors. This control loop can be also overridden by the user, because we don't only want people to just do those 3-4 behaviors that we implemented. We want you to write your own behaviors. And I think that the best way is that you have your code running on your laptop or Raspberry Pi, and then you just produce velocity commands. So when you publish on the CMD-val topic, the robot will listen to those commands, and this will be able to just take control over the robot and move it around. So this can be used not only for teleoperation, but for any kind of autonomous behavior that you want to implement in your own logic. Sorry, in your own laptop or platform. Last topic I would like to talk about is an interesting challenge that we had when developing this robot, because as I mentioned before, some of these components are reused between the Create tree and our Roomba robot. In particular, all the lower level sensor processing is exactly the same. We didn't want to use the same ROS2 messages, services, and actions that we use internally for a variety of reasons. First of all, those are not standard messages. We wrote custom ROS2 messages. They are suited for our needs and not very user-friendly. Moreover, those messages were developed not to be exposed to the public. I mean, they don't have any secret inside, but simply we don't guarantee stability or backward compatibility. Whenever we need to change them, we change them. For this reason, we needed to define a more stable layer to allow the users to rely on stable interfaces to communicate with the robot. For this reason, we had to add an additional ROS2 node in the system. This acts as a layer between all the computations that are running on the robot and the interactions with the user. The ROS2 nodes are also that are, let's say, not user-facing. So again, the sensor processing mostly are in a ROS2 hidden namespace. This is an interesting feature that we took advantage of. It provides a very nice isolation of the component. It's just a namespace. It's not any privacy or security thing. It's just for really be able to easily identify which components you can interact with and which not, rather than having a very complex ROS graph where some components are not accessible. Okay, and after I gave you this overview, I want to go a little bit more now into the challenges and solutions developing the Create tree. As I mentioned, performance is the main challenge that we had. In particular, even if ROS2 improves upon ROS1, we still had to do a lot of work to be able to fit those amount of ROS2 capabilities on the robot. And this is because if you just use ROS out of the box, you probably would have a very high resource usage, much more than the robot can afford. Here I'm going to talk about some of the solutions. Most of them have been either heavily implemented by us or we've made important contributions to them. And they are all available open source. The first one is single process optimization. As I mentioned before, when in a ROS2, you can have multiple nodes running in the same system. This is critical for RAM usage. There's a paper that I co-authored last year where we showed a lot of comparisons between running nodes in the same process or in multiple processes in the same machine. The evolution of the RAM usage is actually very concerning. There is an almost exponential increase in the RAM usage with the number of nodes if each node is in their own application. On the other hand, if you use composition, which can either be dynamic or manual, you can see that the RAM usage increases very little with the number of nodes. The main reason for this is, again, because of the DDS. The DDS will allocate a lot of resources in each process. Also, the topology of your ROS2 graph will affect the RAM usage. It's important to keep your graph simple. If you have a publisher with a lot of subscribers, that will use a lot more resources, a lot more RAM than a pipeline approach. So I think that it's very important to try to have a pipeline because it's clearer for your application and also more performant from the RAM usage point of view. Again, here you can see some data. If we run a benchmark application using FastDDS, which is the default DDS implementation of ROS, this uses 70 megabytes of RAM. If we remove FastDDS, we develop the so-called stub DDS. This is just a stub layer for measurement purposes. But you can see that in a ROS2 application, almost half of the RAM usage comes from the DDS. So DDS is a very complex piece of software. It has a lot of settings and it can be fine-tuned. It's not trivial, but through configuration, you can drastically reduce the RAM usage of your application. There's a link here. I'm going to share the slide as well. And you can find the configuration that we run on Create3 to reduce the RAM usage as much as we can. Because we need the DDS. I mean, the other solution would be to not have any DDS, but then the robot would not be able to communicate with the outside world. The other important reason for going single process is latency. Again, you can see in the plot here on the right how the latency evolves with the size of the messages, depending on whether you have a single process application or a multi-process application. Single process, you are in the order of microseconds of latency, regardless of the message size. On the other hand, with multi-process, the latency quickly increases to several milliseconds. This is not really sustainable when you want to implement 50 Hz or 100 Hz control loops. This is possible thanks to the so-called intra-process optimization. It's a feature that needs to be manually enabled when you construct your ROS2 nodes. The other main reason that allowed us to make the robot is the development of the events executor. I mentioned before that the executor is what takes care of executing your callback. So whenever you receive a message, you do something. This is a critical component. It does something whenever a message is received. So it needs to be as fast and as optimized as possible. We developed the events executor exactly for this purpose. It's different from the single thread executor, but it does everything it can to be as fast as you could. And you can see that both the CPU usage and the latency are drastically reduced. The events executor has been recently integrated in RCL-CPP. So since ROS2 Iron, everyone can use that. And then we have the remaining open problem on Create3 and ROS in general, in my opinion. All of the optimizations that we worked on are for single process applications. Remote communication, besides being not very stable, as mentioned before, is also extremely expensive. When the Create3 is in its idle state and no one is interacting with it, the CPU usage is around 55%. However, if you just subscribe to all the topics, the CPU usage on the robot increases to almost 90%. This is additional CPU only used to send the data from the robot to the laptop. And all this CPU is utilized in the DDS layer. Most of it is in the DDS layer, a little bit also in the network stack. The topology of your system, again, is very important. Having a lot of very small topics that publish at high frequency is not good for DDS. You can see here some data that we measured. If you produce 1 megabyte per second across 10 topics, so for example, 100 kilobytes per topic, that's only 12% CPU, which could be acceptable. But on the other end, you have still 1 megabyte per second, but across 100 topics now, the CPU uses up to 50% almost. Even if the total amount of data you are sending over the network is exactly the same. These are open areas where DDS should greatly be improved, or a different middleware for ROS should be explored. I also have a section here about how to build the application. I think I'm a little bit late. How much time do I have still?
Yeah, we need to wrap it up.
Okay, so yeah, I'm gonna skip this section. It's honestly not that interesting. And I'm gonna wrap it up with these. These are some data that we collected from the creative community. We have a forum where people can ask us questions. And we tagged all the questions. We noticed that a lot of the Create3 users struggle with the ROS2 basics. This is very simple stuff like how do I install ROS, how do I build a ROS package? And those are things that are explained in the ROS documentation, but we think that the ROS documentation is not that good for very beginners. It assumes a non-negligible amount of Linux expertise and computer science expertise. So for this reason, we developed some tutorials for very beginners, very easy to follow, to just build your first packages of ROS2. The other topic that you can see here is the middleware. In particular, these 20% of questions around the middleware really boils down to a single question. Why can't I communicate with my robot? Or why am I losing connection with my robot? Everyone keeps asking this, and unfortunately, it's not easy to provide an answer. I mean, we define this troubleshooting process. Camp, you mentioned before, people told you to try a different middleware, to try unicast versus multicast. That's really what we try, because there's a lot of different components that affect this problem.
Yeah, I also switched over to Cyclone from Fast DDS, but I got the same symptom.
Yeah, exactly. I mean, it depends a lot of your network. For some people, Fast DDS works great. For other people, Cyclone DDS works great. Ultimately,
well, it sounds like I need to connect it to a Raspberry Pi and use that Wi-Fi.
Yeah, that's probably one of the best solutions. In general, DDS has a lot of knobs that you can tune. The problem is that configuring the XML profiles of the DDS is not easy. I mean, I do that a lot, but still, it's very complex. There is documentation, but it's not easy to follow. There's a lot of different options. So this is a major problem for user experience in ROS, in my opinion. We are trying to come up with a quick way, maybe with artificial intelligence or anything, to provide easy to use configuration for the different use cases. So that
it looks like Dillo has a question there. Dillo, you want to ask your question?
Yeah, I noticed that there at ROSCON this past fall there was, and also since then there's a DDS. I don't know if it's a different version of DDS or if it's an expansion on Zeno.
That's very common. It's not
I was wondering if there's like any, have you looked at that at all? ZNOH?
Yeah,
ZNOH?
Yeah, we looked at it. It seems very promising. The problem is that in its current state, Zeno is not usable as a standalone middleware. it requires a Cyclone DDS. So you need to run both Cyclone DDS and Xeno in your application. It wouldn't fit on the robot.
Okay.
Intrinsic, Open Robotics, and other maintainers of ROS are now developing a new version of Xeno, which will be a standalone middleware for ROS2, not based on DDS. And one of the main reasons is exactly to address these problems, because these are problems that all the ROS2 users are having. They have problems communicating with their robots, and it's hard to fix that. So yeah, that's the first version of the new RMW Xeno should be available in late May, when the new version of ROS2 is going to be released. That's going to be only compilable from sources, so no, you can't install that from Debian packages yet. It's still a first version, but that's where a lot of the community is pushing for.
Alberto, can we get a copy of your slide?
All right, thank you, Alberto.
So I can see some of these slides you skipped over.
Can you repeat, sorry?
Did you hear the question? Can we get the slide deck so we can see the slides you skipped over?
Oh, sure. I'll send the slide deck to Camp later. Actually,
yeah, send it to me, and we'll get Al to put it in our archive.
Sure. Yeah, I'll do that.
Also, Scott.
There was a question from Scott Monahan. I think, can you run? I don't know. Maybe Scott, you could say the question yourself because I didn't see it clearly enough.
Oh yeah. So I see the question in the chat now. Is that the question?
Yes.
Yeah.
No. So the question is, can we use Create3 framework with the standard i3 and control the cleaning functions of the robot? No, you can't. The i3 at the moment is only a vacuum. It doesn't run any functionalities through which you can communicate with it. The navigation application is completely different, and so at the moment this is unfortunately not possible. I say unfortunately because I would love to do it.
Cam, are there other questions in the chat?
Okay, yeah. Yeah, I mean, I think that this covers everything I want to present you. Just quickly mentioning that we are using Create3 also internally. We use it for prototyping new sensors. So in the same way as people could experiment with it, we do it also internally. We do hackathon where people do any type of things like soccer competitions, or they try manipulation. They did this thing where you can provide dog food out of the robot on a Create3. So we do a lot of interesting stuff with that. But we also have a very nice community. There are several people that are posting in the Create3 discussion forum showing very cool stuff, similar to what you guys showed today. So I think it's a great thing. And yeah, I mean, this is really everything that I had today. Let me know if you have any question or anything I can help you with.
Thank you very much, Alberto.
The video is worth every penny.
What's next,
Any other questions out there?
Awesome presentation, awesome job. Thank you very much for taking the time to do it. One real quick question, and it's kind of related and not really related. It's just, I don't know why the remote controls for the Roombas are no longer available. Is that something that I could just jury rig and figure out and guess a solution to make my own?
Unfortunately, I have no idea. I didn't even know we had remote controllers.
Yeah, you seem to have them. They're just infrared, and then they just kind of discontinued them. I just thought, well, that's really weird. But okay, no worries, all good.
I'll look it up. I can try to look it up, and if I get some meaningful answer, I can get back to you.
Well, if we had the protocol or the codes for it, then we could easily, produce something that could produce those codes. So
Yeah, I mean, I know that for some of the older Roombas, some people created some ways to hack the robot and communicate with it. So I think it really depends on which robot you have and which robot you want to interact with. But there should be ways out there to develop your own stuff.
Thank you.
Any more questions for Alberto?
So, so how much can we get one of these for? That's that is a good starting kit with everything you need.
So at the moment, I think that we sell the Create 3 in North America for $300.
$450.
Okay. There's a discount for students and educators. And yeah, that will give you the robot with all the onboard sensors. In theory, all you need.
I recommend it. It's a really good value, and the suspension on it's excellent. It's better than the BotVac. And I got the LD06 LiDAR for $100, and its ROS package includes the laser to baselink transition. So I literally Velcro the LD06 LiDAR onto the Create 3. You boot the Create 3 and it exposes all these ROS topics, including command velocity, and you get your keyboard and you drive it around and run Slam Toolbox, and you're automatically mapping. So it's a pretty good experience.
So it's 450, and unless you have a student discount or educator, right? 450.
450 is the price.
Yeah, so it's it's a chunk. It's
pricey. BotVac may be a better value at 150, but like I say, I got this and I put the LD06, and it's a current product. It's supported. There's a great user community, and it's a good value.
Right. Yeah. It's definitely.
Any other questions? Okay. Well, Alberto, thank you very much for coming out and doing the presentation. And at this point, we'll adjourn the meeting and we'll go into random access. So we'll just hang out until the security guard comes and kicks us out. Okay. Thank you very much. Last Wednesday of the month, we'll do this again. Same robot time, same robot place. We've got some special interest groups going on. The SIG, the Builders SIG, meets on the penultimate Wednesdays, and we have our Ross discussion group on Tuesdays, and on the I think it's the third or fourth Thursday, there's the voice intelligence group. So a lot going on. Everybody's on the Brew Robotics Club mailing list. We're a Google group. This is where you get all your robot. The fourth Wednesday. Thank you, Thomas. That's all. Thank you very much.
Thursday, Cam. Thursday.
Second Thursdays.
Okay,
Fourth Thursdays. That's the voice intelligence group. Join the mailing list, the HBRC mailing list. It's a Google group. That's where you get all your robot news there.
I'm stopping the recording.
The recording has stopped.